YouTube users, ladies and gentlemen. This is the array of stuff I got from the previous video, tearing down a small-ish vending machine stroke coffee machine. Did lattes, did espressos, did hot milk, did all sorts of weird and wonderful conversations. No. Had weird and wonderful combinations of stuff that it created. So good job I'm using my widescreen wide angle lens, because I couldn't fit the rest of this in with a normal size lens. This is the kit lens, by the way, 15 to 35mm, and it's good because there's a wide screen, so you can get a lot more in shot, or fit a lot more in shot. So definitely worth getting or using if you get the camera with the kit lens. Definitely worth it. So this is the stuff I got out of the machine. I didn't take all of the bits and pieces out, only because I'm not going to use all the other bits and pieces, so I thought I'd just take one of kind of each portion. So like we have like the display screen, which is always good. You can stick it on an Arduino or power it and just create stuff yourself, so that's reusable, so I definitely thought I'd take that. A generic 24-volt motor, not going to use it for anything, but you know, worth keeping hold of, I suppose. A solenoid, which I've never had before, or never played about with before, again 24-volt. What looks to be the power supply circuit, obviously because of a massive, great, huge capacitor there, and what looks to be the logic board circuit, because it's got the processor right there where it says Linux BM3, which I suppose is the software. It's probably some sort of Linux small system software or something. I haven't got my oscilloscope, otherwise I would have probed the where's the JTAG header, this header here. Would have been able to have a look, see if it spat out anything. The coin acceptor, if you call it that, or coin reader, so when you put your coins in, it's a self-contained module. All I know is it needs a little 2-wire feedback and a power supply, and it's all contained in the one kind of system, so that's pretty cool. So I thought I'd definitely have that, and of course your obligatory power supply. Funny enough, talking about power supplies on yesterday's uploaded video, this is a linear supply. So you have your 240, that's your RF, what do you call it, IEC connector, which has a loop filter in it. Nice toroidal transformer, 0 to 18 volt output, which will be on those two there. So let's go in one by one and have a close-up look at what we have contained here, and see if there are anything worth saving, or if there is anything of interest we can have a look at. So let's go and have a look. Yeah, so this is the first board out of the couple that I got out of that machine that you see me sort of quickly tear down and grab stuff out of. So I say this looks to be the power supply board. Reason why I say that, obviously you've got these 3-pin Molex connectors here, and also these 4-pin Molex connectors, which, if you're not too sure what the board actually does, those are generally a dead giveaway. Also with voltage regulators as well, being near connectors, that's also generally a dead giveaway on what's a power supply and what isn't. There are a few voltage regulators dotted about, and some transistors, discrete transistors. I'm trying to find a diode bridge, because obviously the power comes in, it's AC, because we've got that particular toroidal transformer. And what I don't see, that could be a diode, but there's the bulk capacitor, so I'm looking to, there we go, 1, 2, 3, 4, see those 4 discrete diodes? That will be the diode bridge. This will be the DC bulk capacitor, and then the output from that will be the voltage we'll require. That looks to be just an inductor, kind of looks like a diode bridge. But you see here, there's quite a few diodes here, and what I think they're used for with this connector here is actually the different motors. So there's a lot of logic and motors going on here. So these are probably transistor packages which drive those various motors on the system. And these diodes are used for sort of back EMF. So basically if you're running a motor or something that can switch at higher loads or whichever, or a relay for example, you need to have a back EMF diode to prevent any voltage spikes going back into the logic. So if you're powering a motor from a logic chip, say 3.3 volt, and you're powering your motor at say 12 volt, the last thing you want to do is have a power spike where that 12 volts comes back into the 3.3 logic, because it'll blow the arse out of the chips. So that's what these are for. Basically, we've got a couple of power resistors here. I'll see some more. These are basically just discrete logic chips, so they'll be driving the motors here, as I said. That looks to be a power supply circuit here with the inductors, the capacitor, and diodes. Voltage regulators over the place. This looks to be an opto isolator, which we'll also have a look at. These seem to be single-sided boards. There's nothing. They're not double loaded or double-sided. As you can see, there is literally nothing on the bottom, no components whatsoever. So it suggests to me that they're obviously saving costs and sort of spinning one board with everything on the top side, as opposed to having a double-sided load with components on the opposite side. Just saves costs really, but yeah, as I say, power outputs and inputs here, discrete logic for driving motors, a few voltage regulators, and some diode bridging capacitors and power supply circuit here. So not sure what that chip there does, maybe a timing controller. This is definitely discrete logic for driving motors and stuff. But there's one thing I did see on this board which is actually quite interesting. You see that there? That looks to be a socketed fuse, which is a surface mount type fuse. I've not really seen that very often. Kind of cool though, because if it blows the fuse, you can just take that out, whip another one in, and you're good to go again. So again, saving costs. So that's a pretty cool idea. But I say, first time I've seen that, a surface mount component in a socket where you can readily change them if required. So that's the first board we looked at. That's the power one. So let's go and have a look at the other boards that we had. See if we go into a bit of detail onto those and see if we can get, or see if we can see how they work and how they function. Okay, easy whizzy, let's get busy. I thought I'd change the angle slightly. Manual focus still. Actually, my multimeter is a bit. There we go, that's a bit better. I always choose manual focus when I'm recording. Reason being, I absolutely hate, with a vengeance, the what do they call it, searching mode, or hunting they call it. So when you've got an automatic focus, although you can move your stuff about and get it in focus of the frame, you do get like a hunting effect, which means every time the frame changes, you get a like a what do you call it, effect. Let me show you what I mean. See if I can actually change. Don't think I can. I'll leave that for now anyway. Anyway, I digress from the video that I'm producing right now. Let's get that there. Right. Okay, so yes, getting back to the video in question, I did review this board here, the power supply board, out of this coffee machine. I later realised that I forgot, as an idiot, to take the additional connector plugs to power this secondary board. So basically what I'm going to do is have a quick run through this board. I'm not going to be able to power it and do anything, which I was hoping to do. So I'm just going to quickly run through this board. I mean, it's not much of it really. I mean, it's just some logic and the OS for the screen, which is down here. This screen here, which is a standard screen you can buy from literally anywhere, eBay, Amazon, Banggood, all that sort of stuff. It's a generic type screen. Can be used for other applications, so I will keep that, that's good. But this board here, as I say, there's not much I can do with it. I was going to go through and look at the chips and stuff, but I can't be bothered. It's just no point really, is there? So we had a look at this board. This was alright, power supply, various outputs. I did notice though, where I took the 240 connector off this side, only half this board actually powers up. So putting the power in this section with this 2-pin plug only had like half of the stuff powered up. So again, it didn't really do much. What I did do, which I didn't manage to capture on video, is short these 2 pins out while it was on. It's a nice big spark, and didn't blow anything, but would have been nice to capture, but hey ho. That's the beauty of YouTube, I suppose, doing stuff randomly. So yeah, we've looked at that board, we'll forget that. And what I was going to focus on is actually toroidal transformers. This one, as you see, or can see maybe, this has got the ratings on the power supply itself, so 0 to 18 volts, 4.4 amps output, which is pretty good. I mean, this is not a typically heavy transformer. Obviously, it's got no center tap, so it's literally just 2 pins on the output. Obviously, it's AC, there's no DC, there's no diode bridges or anything, and a nice little IEC connector, which is just 240 in. No need to earth it, because there's nothing else really going to be touching here. It's all wrapped in plastic and insulated. It also has a thermal fuse at 130 degrees, which is pretty good. So it will cut out at that temperature. So if for some reason it's shorting, or something on the board that you're powering, or device that you're powering is shorting, this will get very hot and then actually cut out. So that's quite a good little feature. What else did I get out of it? Yes, this was the other device, or the other piece of equipment I got out of the coffee vending machine, if you like. Again, I was going to open this and go through it, but it's similar to my other video. If you've not seen it, have a look. I'll post it down below, or put a link down below somewhere. Just got a series of sort of readers and stuff which detect the coins going through the system, and obviously outputs at the bottom here. Not really much to it. I mean, yeah, I was going to, but I really can't be bothered, and they pretty much serve the same purpose. They'll pretty much do the same thing, so I thought I'm not going to bother bugging about with that either. So a bit of a wasted video really, but I may do a separate one on power supplies like I did before, just get into a bit more detail as to how they work and what you can use them for. The solenoid as well, which I did play about with, not very powerful at all, but I might show that working as well, just to give you guys an example. And the motor, oops, and the motor as well, 24 volt DC motor. This is the whipper motor, it was called in the machine. So obviously this did the whipping of the cream or whatever it is you had in your coffee. So it's pretty fast. I mean, I don't know what the RPM is on here. Oh, there we go, 10.7 thousand revolutions per minute. So it's quite a speedy little motor. So I may show that in a future video as well. So I'm going to leave it there, leave it as it is, and I'll upload to YouTube and let me know what you guys think. So catch you next time. Please comment, link and subscribe and all that jazz. I look forward to seeing you very soon, YouTube users.